In this video, we'll discuss angles. Now, an angle is an amount of rotation between two rays with a common vertex. Now, we sketch that by creating a point and then having two rays coming from that point. We can label it by either using the angle symbol and just the vertex if we only have a single angle. If not, we want to go from a point on one ray, the vertex, and a point on another ray, and that order matters. The vertex always has to be the middle point labeled for the angle. We can also at times see a lowercase script letter used inside an angle, especially when we're dealing with multiple images and multiple angles within that image. So let's look at this example here. Here we have this angle. We could call it angle B because there's only one angle in the image. We could also call it PBS or angle SBP, but in both those cases, B is the vertex. We could not go angle BSP because that would be the angle going from B to S to P. That middle letter is always our vertex, so don't use that. Now, when we measure angles, we use a protractor and we measure in degrees. And we have to pay attention to how we use that instrument, and we'll go through that in class as well. We use common terminology for the angle types as we're measuring. Acute angles measure less than 90 degrees. Right angles measure exactly 90 degrees, and obtuse angles are always greater than 90 degrees. So if we look at some images here, this is a 60-degree angle. So angle RLN would measure 60 degrees and be acute. Here, this symbol tells us that this is a right angle. So angle DAE is a right angle. Now, when we start to intersect lines, we start to recognize different relationships that can occur. If the lines intersect at right angles, we call them perpendicular lines. So say we have that line LE is perpendicular to line PD. That upside down T means perpendicular. That would mean that we have a right angle in all four of these intersections. They're all 90 degrees. Now think about what happens then. If I think about the four intersections together all being 90, they sum to 360 degrees, which is another relationship. That whenever two lines intersect, the four angles measurements will sum to 360 degrees. So it doesn't matter if they're perpendicular or non-perpendicular. And think about it, and here's an image to help. I can go around the circle. A circle's 360 degrees. So if I fill in those images there, I have vertical angles, which are congruent, and then I have these lines which have to add up to 180 degrees, hence why it's 360. So if this was a 120 degree angle, the opposite, the vertical angle, would be 120, and the other two would have to be 60. Now, when we start dealing with parallel lines, we start to have even more relationships. These are when two lines never intersect. And if we construct a transversal, or a line that goes through both of those parallel lines, we start to have unique relationships if the lines are parallel. For example, corresponding angles in parallel lines cut by another line are congruent. So let's say we have this image where we know that RS is parallel to FH, and we want to label what are the corresponding angles, because they'll be congruent since the lines are parallel. Well, in this case, RGM and FWG would be corresponding. Then RGW and FWB would be corresponding. Then we'd also have BWH and WGS would be corresponding. And then we'd also have MGS and GWH that are corresponding. So we have four sets of corresponding angles in this image. And the sets of corresponding angles are congruent to one another. So their angle measures are the same. Another relationship is that the alternate exterior angles will be congruent if the lines are parallel. So let's look at the same image. Alternate exterior means on the outside and on opposite sides of that line cutting, or the line that's called the transversal. So here that would be RGM and BWH, or it would be FWB and MGS. They're alternate exterior angles. Now, just like we can have alternate exterior angles, we can have alternate interior angles being congruent if the lines are parallel. Only if the lines are parallel do we know this to be true. So if we look at the same image, we would have that RGW is congruent to GWH, and FWG would be congruent to SGW, and those would be our alternate interior angles. Now, one other unique thing, because of these congruences, all the angles are either congruent to one another or they will be supplementary. In other words, their measures will add to 180 degrees. So if you know one angle in a parallel line cut by a transversal, then you will know all 8 of those angles by just following these relationships.